This is my version of the multi-paradigm project, PLC 4, offered by Pauline on PLC Dojo or on Udemy. So let's go online here and let's run through it. Log in. You want to create, yes. For this one, the project itself doesn't include an HMI screen, but to make it easier to view, to look through the operation of it, I just call upon some of my skills that I learned from HMI from PLC 3, process visualization, offered by Pauline again, and created this HMI screen just to make it a bit easier, just to view and see what device is running when, instead of just going through looking at tags and being all over the place trying to find them. And start running this, and so you can see we're in offline mode. Mode is 0. I just created a couple more screens here, an alarm screen, and just set point really, but I just put this here to kind of simulate this, so if you're just looking at the visualization, you don't necessarily have to be looking at your PLC.prog. Let's go back to the overview screen and start the system up. Let's see, it went over init and initialized all the variables. Pumps running. Alarm, low tank level. So in startup, I probably could take this out so it doesn't create this low tank level alarm, but I've programmed it so it goes through startup even if this is present, as long as it didn't reach the upper limit, then it wouldn't jump over to stability. Yeah, but if it reaches, go through the startup process and the alarm still exists, then it will jump over to stability. Mixer has to be running for a minimum of 30 seconds before it moves to operation. And as you can see, this one here is mimicking this. I guess I could have put these on there too, but nah, not really necessary at the moment. So we're in operation where the valve opens. You see the valve came on there, and it constantly drains the tank. The pump comes on when the level is below 20%. Tank level is below 20% after 5 seconds, or for 5 seconds. So it's showing your mode there. Alarm. Yeah, as you can see, the system here it's on, pumps on, heaters on, mixers on, valves on. The heater should be going off anytime soon. Yeah, there you go. Pump's gonna keep running until this gets up to 80% and is above 80% for 5 seconds. Over on this side, you can see, let's see if we can open each of these. See what's going on. Initialization. Upon entry of initialization, then it moves a 1 into mode. Offline moves a 0 into mode. It's the entry. Offline. When it comes in here, it shuts off all the devices. Then it moves to startup. See if we can find startup entry. Startup is written in structured text. When it comes in, it moves 2 into mode, and the counter goes up by 1. I've done both. I've done this in both the ABB platform and in Codesys, but I kind of like working in the Codesys environment a bit more, just a bit more flexible. In startup mode, that's your code there. You try to just do a little bit more documentation on there, so if I come back to this sometime down the road, I don't have to spend too much time trying to figure out what's happening in here. So yeah, just a little bit of documentation, so saying what the controls is doing in this mode. Then operation entry, operation there. Operation, I think, was function block diagram. Still try to do a little bit of documentation. It's not as much, but the function block diagram is more self-explanatory than your structured text. Stability. Upon entry of stability, and you load 4, put it into mode, and your stability active. Once again, I try to do a little bit of documentation. It's not a whole lot in here, but at least it will help me to remember the logic I've put down without busting my brain. And stability, I think, has an exit. And it updates the time. When it exits. This one here was let's go back into stability active, but I was experimenting with 2 different methods of logging time. This one calling a function block, the other one with just using timers. So if we can go back into stability active here, over here I actually was logging the time in sequential function chart. Logs the time it goes into stability mode. Let's experiment with using the RTC, this function block here. It seems to be a pretty handy function block, but you can use it to count time, but I guess you have to save the time it logged out and put it back into the input here to continue counting from there. Okay, let's try and get this thing into stability mode for a bit. Let's go over here and let's set the drain rate 600. Try and bring it into a low level alarm. It's in stabilization, alarms active, low tank level. Go over here, and in here find that your time, once it goes in this mode, your time has been logged using the timers here. It's also been logged using the RTC function block, and when it comes out, it logs the time that it's spent in there. Found that the RTC is a bit more accurate than trying to count time it with a timer. In my stability code, I have this 15-second timer, so the system has to be stable for a minimum of 15 seconds before it jumps back up into operation. See if we can add this to our watch list. Add a watch on here. And go down. "15 seconds." Jumps back up there.
Good evening.